So let us take some problems as far as the development length LD is concerned. Now over here the problem goes like this. Calculate the development length LD for the following in terms of the diameter of the steel or the steel reinforcement in tension. Let us just try to understand what all things have been given over here. We have been told that the diameter can be substituted. So we have to find the value in terms of diameter. We have been also told that the steel is in tension. Very important component over here, that the steel is in tension. Now when we look at the table over here, we have been given the different types of concrete. So one is the grade of concrete is M25, grade of concrete is M30, grade of concrete is M35, and the grades of steel are 415 and 500. So we have to find out what would be the LD for M25 and Fe415, similarly for M30 and Fe415, and M35 and Fe415, similarly M25 and Fe500, M30 and Fe500, and grade M35 with the grade of steel as Fe500. Now the development length of the reinforcement is given by the clause in the IS code 456-2000, clause 26.2.1, page 42. Now when we look at the page 42, LD is given by phi into sigma s upon 4 tau bd, where phi is the nominal diameter. So over here we need not substitute the values, so we have to get the answer in terms of the diameter. Sigma s, we all know that the stress in the bar at the section considered, that is at the design load. Okay, at the design load, how much should be the LD? Okay, and tau bd, the design bond stress, which has been already provided to us in table 26.2.1.1, page number 43. Now the value of sigma s is equal to 0.87 Fy, as we have seen earlier. Tau bd is the design bond stress which has been given in this particular table. Now when we are looking at M25 and Fe415, for M25 the value of the bond stress is 1.4. So when I'm considering M25, the bond stress will be taken as 1.4. But we have seen in the codal provision that whenever we are using the deformed bars, if we are using the deformed bars, the bond stress will be enhanced. The bond stress will be increased by 60%. So let us look at what is happening over here. Since the bars are HYSD bars, the steel grade is Fe415, they are not plain and rounded bars. They are bars with projections, bars with deformations, so they are HYSD bars. So the bond stress which is obtained in M25 over here in this, from this table, 1.4, is enhanced by 60%. So instead of taking it as 1 into 1.4, instead of taking it as 1 into 1.4 equal to 1.4, we are taking it as 1.60 into 1.4. So 60% increase to 1.4. So we are getting the value of bond stress as 2.24 Newton per mm square. Now we are looking at the formula. Phi sigma s is 0.87 Fy upon 4 tau bd. So phi remains as it is, 0.87, Fy is 415, 4 tau bd is calculated over here. So development length comes equal to 40.3 times the diameter. Now at the same time, instead of Fe415, if we are having Fe500, then what will happen is that for Fe500 also, since the concrete is M25, the bond stress remains 1.4. Since it is Fe500, it is not plain and smooth bar. Okay, so it is a HYSD bar, so the same calculations get repeated. So enhancement by 60%, so tau bd becomes 1.6 into 1.4 comes to 2.24 Newton per mm square. Substituting over here, phi into 0.87 into 500 divided by 4 into tau bd, which is 2.24. So we get development length LD equal to 48.55 diameter, 48.55 times diameter. Suppose the diameter of the bar is 10 mm, then the development length for M25 and Fe415 would be 40.3 multiplied by 10, that is 403 mm. For Fe500 with the diameter 10 mm, that would be 48.55 into 10, which is 485.5 mm. Now coming to the next one over here for M30 and Fe415. For M30 it is 1.5, enhancing by 60% means multiplying by 1.6, we get the value as 2.4. So phi into this value is 0.87 into Fy. Fy is 415 divided by 4, tau BD is 2.4. From here we get the development length LD equal to 37.61 times the diameter. Similarly for M30 and Fe500, the development length LD comes equal to phi into 0.87 into the value of Fy becomes 500 divided by 4, and this value which we have already calculated over here comes to 2.4. So the development length LD equal to 45.31 times the diameter. Coming to the third one, it is M35 and 415. For M35 the value of the bond stress is 1.7, enhancing because it is HYSD bars is with deformation, so 60% increase, that is 1.6 into 1.7 comes to 2.72. When I substitute over here, it becomes phi into 0.87 into Fy. Fy is 415 divided by 4 divided by 2.72. So this gives me the development length LD equal to 33.18 times the diameter. Similarly for M35 and Fe4 500, the development length is phi into 0.87 into 500 divided by 4 into this is the bond stress, that is 2.72. So finally we get the development length LD equal to 39.98 times the diameter. Now when we summarize, we get the things over here like this. For M25 and Fe415, the development length is 40.3 times the diameter. For M30 and Fe415, 37.61, and then for M35 and Fe415 it comes to 33.18. For M25 and Fe500 it comes to 48.55. M30 and Fe500 it is 45.31, and for the last one it is 39.98. So this is the way we calculate. Now in this case we had the bar in tension, we had the bar which was HYSD bar. Please remember, if instead of HYSD bar, that is Fe415, Fe500, Fe550, if instead of any of this, suppose it is 250, Fe250 given, then please remember that is plain and rounded bar. No increase or no enhancement of the bond stress is permitted for Fe250 because it is plain and rounded bar. This enhancement by 60% is permitted only for the deformed bars, only for the HYSD bars.